Hello students, I'm back with 3.7, elasticity of demand. We've done A and B, where we've created the demand equation and graphed it. Now we're going to talk about something new called elasticity of demand. It measures how demand responds to a change in price. The ratio that is considered is a percent change in demand over a percent change in price. So we're looking at and comparing a change in demand with a change in price. So our E of P, so that's elasticity depending upon price, is now a percent change in demand is a delta X over X, that's what percent change is, over delta P over P, that's a percent change in demand over a percent change in price. That's how you would calculate percent change, and economists have chosen to make that a negative quantity so that all the results are positive. So that is just something that is accepted. And now all we're doing is taking this fraction, dividing by that fraction, which is that fraction multiplied by the reciprocal of that fraction, and then a little rearrangement of variables. And we've got a delta X over delta P, then we pull in our calculus, and voila, here's the drum roll, please. E of P is equal to negative P over X times dx dp. Now I do know that I have variable X in here as well as P, but when we do this problem, we are going to I use this. Now I think Math Excel might be using this more, but I like this better. So just note that Math Excel will be using this because everything's in terms of P. All right, so we are going to be calculating our elasticity of demand on the problem above, which is an equation. So let's see, where is that? I'll turn this over. It says C. Find the equation E of P for this product. So we're talking about these sodas, and we're going to find E of P for this product. And I'm going to start here. My E of P is equal to this equation right here. So that's the one I'm using. And note that X is this negative 26.7P plus 186.7 from above. And let's take the derivative of that. So we want to take the derivative of X with respect to P. Now it's been a while. It's been a whole spring break since we've done that. Do you know what the derivative is? The derivative is negative 26.7. And then the derivative of that is 0. So the derivative of this in front of the P, you just put down that. That's the slope. And the derivative of 186.7 is 0. So now we have everything we need to substitute into here to make everything in terms of P. So we are going to substitute in dx dp and the X so that everything is in terms of P. So let's see. So notice that this negative, which can be a nuisance, I always put it up in the numerator just to save things from happening down in the denominator. So that negative can go to the numerator, the denominator, or just right outside. I just put it up in the numerator. Trust me, it's a good idea. And then the X is this linear equation times, and then dx dp is just this constant right here. So look what I've done. I've substituted, P just stays. X, I put in this. And dx dp, I put in the negative 26.7. Now I'm going to simplify this. I'm going to put the negative P and the negative 26. See, this is just over 1, right? So all I can do, or I can, multiply the numerator and the denominator, and that will give me 26.7, because of the negative times the negative is a positive, and I get 26.7 over this, and this is your equation, your E of P. And I wrote over here, this measures the elasticity of demand for these sodas for different prices. So we can plug in different prices of P and calculate the elasticity of the demand. All right, so that is part C of this problem. I'm going to turn this off and we'll come back and do part D.